Hi, today we are going to see product of sum, max terms and canonical form in lecture 7, and this is Benila. So as per the syllabus, it's product of sum, canonical form and then the max terms. So we know that the occurrence of a Boolean variable in original form or in a complement form in the Boolean function is called literals. So these literals can be arranged in two forms, either sum of product or product of sum. So the sum of product we have seen it in the previous lecture. So today we are going to see product of sum. So Boolean function expressed as group of sum term combined with AND operation is called product of sum. So the sum term will be grouped using an AND gate, that is called as a product, right? So the standard form is, so this is here this is going to be one sum term, this is going to be the second sum term, this is going to be the third sum term. So the product, and using AND gate we are just multiplying, so the product of the sum term is called POS. And then canonical form, what is this canonical form means? Each and every term, sum term should have all the literals either in original form or in complement form. So in this expression totally we have three literals, that's A, B and C. But here C is missing, here A is missing and here it is C is missing. So in the canonical form, if all the term is having all the literals, it is called as a canonical form. So here you have two sum terms. This is going to be 1, this is going to be 2. In this first sum term also all three literals are available, and in the second sum term also all the three literals are available. So this is the difference between standard form and canonical form. In standard form, so it's okay if all the literals are not available, but in canonical form all the sum terms should have all the literals. So let us see the conversion of product of sum to product of max term. What is the procedure here? First find the missing literals in each sum term, then add 0 to the sum term. So adding 0 to anything, it doesn't change the value. So add 0 in the place of missing literal of each and every sum term and replace it by the product of the literal and its complement, because we know the law A bar is equal to 0. So 0 will be replaced by the missing term of original and then the complement form. Then expand the term by applying distributive law. Then remove the retardant term. So this is the procedure. Now we can see f is equal to a plus b into b plus c into a plus c. So you have three sum term, and the number of literals available is a, b and c. So three literals and then three sum terms you have. Convert this product of sum to sum of max terms here. That is, max term is nothing but the canonical form. So in this form, what is missing? So first procedure is find the missing literals. So here C is missing, here A is missing, here B is missing. Replace that missing literal with 0. So I'm just replacing C by 0, A by 0 as well as B by 0. Then what you have to do is 0 should be replaced by the product of the literal and its complement, right? So here I have to go for C into C bar, here A into A bar, here B into B bar. So and then I have to expand this one by the distributive law. So A plus B plus C into A plus B plus C bar. Then A plus B plus C into A bar plus AB plus C. Then A plus B plus C into A plus B bar plus C. I have expanded using the distributive law. Now remove the retardant term. So A plus B plus C is available here. So I am just removing this one as well as this one. So I am just removing the retardant term. And then I am just checking A plus B plus C bar is available? No. So A bar plus B plus C is not available. A plus B bar plus C is not available. So I am just removing the retardant term, and then the final value will be, so here it is going to be 0, that is going to be this is going to be the max term. So in this max term you should have the original value should be mentioned, that is A should be mentioned as 0 and A bar should be mentioned as 1. So that you have to remember for the max term. So min term it's going to be ulta of it. For A it's going to be 1, A bar is going to be 0. So this is going to be the max term here, right? So this is going to be 0, 0, 0. 0, 0, 0 is 0. Then this is going to be 0, 0, and then this is going to be 1. So 0, 0, 1 is going to be 1. Then this is going to be 1, 0, 0. So 1, 0, 0 is going to be 4. And again this is going to be 0, 1, 0. So 0, 1, 0 is going to be 2. So the canonical form is going to be, so the product of max term is going to be 0, 1, 2, 4, and this is going to be the canonical form where all the term is going to have all the literals here. So we'll see one more problem to convert the given Boolean function to canonical POS. So here they have given this f is equal to xy plus z into y plus xz. So you have to make sure that you should have only sum term. You should not have product term. So you have to use your distributive law to expand this one. So I can write this as x plus z and then y plus z. Then y plus x plus y plus into y plus z. So now it is in the product term, right? Now I have to see how many literals are available. So x1 literal, z1 literal, y1 literal. So totally you have 3 literals. So x, y, z. So now you have to make sure that each and every sum term should have all the literals. So for that one I'll just find the missing literal and then I'm just going to add 0 to it. And then the 0 should be replaced by original and the product of the original and then the complement. Then distributive law, I'm just expanding this one. Then the retardant term should be reduced. So retardant term should be reduced and the remaining term should be taken. And then since this is going to be the product of the original will be 0 and then the complement will be 1. So complement will be 1. So this is going to be 0, 1, 0. So what will be the value here? So this is going to be 1, 0, 0. And this is going to be 0, 0, 1. So what will be the answer here? So 0, 0, 0, 0, 1, 0, 1, 0, 0. So the answer is 0, 0, 0 is M0, 0, 1, 0 is 2, 4 and then 1. So your product of sum should be mentioned in pi. So sum of product will mention in the sigma. So this is going to be sum. So problems for practice. So I have given 3 problems. In this one you have to note down as in this function if they have mentioned the literals you have to use the same literal. You should not change this one. If they give x, y, z, you have to use the same x, y, z. If they are going to give small abc, you have to use a small abc. So if it is small abc they have given, you cannot use a capital ABC or x, y, z. So likewise. Thank you guys. Subscribe my channel for automatic help. Have a nice day.